we finished all of the dangerous, severe weather stuff, right? The death, destruction, and despair. Well, today we're going to deal with weather prediction. You're going to need, guys, 13 of your reference table out. Okay. On page 13, you have station models. Okay. So you're going to need those because that's going to help us to predict what's going on. All right. So when you're predicting the weather, it's based on probability and patterns in general. Okay. The best job you can have is a meteorologist. Why? Because you can be wrong 97% of the time and be able to blame it on nature. Okay. Now, here are the important relationships that meteorologists have got to take into consideration. Okay. How air temperature and pressure relate to each other in terms of the dew point. What happens if the air temperature and the dew point are closer together? Those pressure gradients, are we having a high gradient or a low gradient? Does that mean that we have high winds or low winds? Okay, and also falling air pressure. All of these relationships, you need to know how they interact with each other, right? Because that's going to help us to determine what kind of weather we have in that area. Also, it's going to help us to determine, is it going to be severe weather or not? And also, what kind of a front is moving in? Do we have a cold front moving in and a warm front already there? Is it going to be an extreme difference, which is going to cause that severe weather, right? All of that fun stuff. Oops, I'll give you guys another minute. Let me know when you're done, okay? Good? Okay. So, weather maps and stations. I've been showing them to you this entire unit, but now we're going to actually practice with them. Weather maps and stations. So this is the bottom of page 13 of your reference table. All right, we all have page 13 out. We're all looking at it? Yes. Okay. So this one over here on the left, that's what the actual station model looks like. Okay. The actual station model is going to be very clean. It may or may not have all of these numbers around it. Okay. But you are required to know what they mean. Well, that's where all of this other information comes into play. Okay. You have temperature, and notice, okay, it's temperature in degrees Fahrenheit. All right. We're not dealing with Celsius here. Okay. We have temperature. We have the amount of visibility is half a mile, right? We have our dew point temperature is 27 degrees Fahrenheit. Notice that the dew point and the air temperature are close together, so there's a chance of precipitation. Specifically, what kind of precipitation? Well, this little star here, we go back down to where it says present weather, and that means it's snowing currently in that location. Okay? Then you have the hardest one, which is the barometric pressure, which we will get back to. All right? We have the barometric trend, whether it's going upwards or downwards over the last 3 hours or so. Okay? And the amount of precipitation that has fallen so far. Okay? Then you also have this circle here. The circle in the middle. The black part of the circle, or the colored in part of the circle, tells me the percent of cloud cover. So what is the percentage of cloud cover in this area? According to this station model. 75%. Why? Right. So the black part of the circle is colored in 75% of the whole circle. Okay. Then you also have this line that comes off of the circle itself. Okay, that line is going to tell me the wind direction, where it's coming from. So that line points towards where that line is coming from. Okay, so in this case, it's pointing southwest, so this is going to be a southwesterly wind. The lines that come off of it are going to represent the wind speed in knots. Okay, the wind speed in knots. And now you see you have a long line, and then you have a short line. Okay, each one of those long lines is worth 10 knots. Each one of those short lines is worth 5 knots. So in this case, at this weather station, it is 15 knots, okay? And it actually gives you the conversion from knots to miles per hour. So for every 1 knot, it's 1.15 miles per hour. So if I have 15 knots, I can multiply that by 1.15, and that's how many miles per hour I'm going to have. Okay, so we talked about the weather fronts already. We talked about the air masses, all right? You know what they look like. You know what they are. So we're going to watch a little video on weather stations, okay? It's going to go over how to read a weather station. So, of course, guys, since I'm showing you a video clip, what should you do? Take notes, exactly, all right? And I will be stopping it. You okay? Okay. I know, you're super excited about this.
In this video, we're going to talk about station models. If you look at this weather map, you can see that these teal things right here, these are actual station models on this real-time weather map. You can see February 24th, 2015, and the time span, this is of the Northeast. So you can look here, the teal thing is a station model, and then these green numbers to the side are actual numbers that represent the current weather conditions at specific locations. So our goal for today is to help you figure out what all of this information means on one single station model, and hopefully you'll be able to draw one by the end of this video. So the first thing we want to do is we want to follow along our station model instruction sheet.
Obviously, you don't have a station model instruction sheet. However, what do you think you should be doing?
Looking at page 13.
Absolutely. Let's make it in your notes. Now, it's up to you. If you should probably draw a perfect circle because you're going to be using this over and over again. So, for example, if we're doing this in Binghamton, New York, okay, we're going to basically build up to what our station model is going to look like. Okay?
We also want to have page 13 out of our reference table, which guides us through all of this information. So if you could have that out, that would be very helpful. As I go through, I'm going to kind of talk about this stuff, and then you should be drawing things in your worksheet. So the first thing is that anytime you have a circle that's drawn, that circle is going to represent a specific location. So if you think back to the weather map I just showed you, all of those teal circles that were on there represented specific locations. For example, Binghamton, New York would have its own specific station model. The next thing would be the wind direction. A line is drawn on the circle to represent the direction the wind is coming from. Keyword here is coming from.
Okay, so what I was just saying to you guys, right? So this is going to be pointing in the direction that it's coming from. So with this one, which direction is it pointing? Which direction is this pointing, guys? Northeast. Exactly. So this is pointing in the northeasterly direction, and therefore the wind would be a northeastern wind. Okay?
Okay, all winds are named from the direction they come from. So this right here is the tail in the station model, and we can see that the wind direction would be coming from the northeast. So you should write northeast in there because this is the compass direction that this tail is pointing. So whatever direction the tail is pointing, that's the direction the wind is coming from. The wind speed is also indicated on this tail, okay? These things called feathers are actually drawn in a way to represent how fast the wind is blowing. So if we look here, a whole feather, which is always drawn on the end of the tail, represents 10 knots. A half feather, which is always drawn further down the tail here, is worth 5 knots. If you look at your reference table, you can actually see this. So let me show you. So on page 13 here, we can see that in this one, you can see the whole feather, which is longer, which is 10 knots. Our half feather is 5 knots. So if we were reading this station model on a weather map, we would know that the wind was blowing at a speed of 15 knots. 1 knot is about 1.15 miles per hour, but mostly we report that in knots. So if I wanted to do 25 knots, all I would do is I would add another whole feather here, and all I have to do is add them up, and I get the speed that I'm looking for. Remember?
Okay, so one of the things that she just mentioned that I want to show you is that when you have a half of a feather, okay, it is not drawn at the end. Okay, if it's only, let's say your speed was only 5 knots, you are not going to draw a half at the end. Because how am I to know, as the person reading it, that this is different than this? How do I know that this isn't your long feather? Right? So when you draw a 5 knot wind, here's your tail, you're going to put the short one indented. Can you guys at home see that? Guys at home?
Yeah.
Can you guys see the difference? Right? So this is still 5 knots, but I want you to draw it on the inside versus this one where it's at the end. Because I'm not going to know, or whoever's grading your stuff is not going to know, is this a short one or is this a long one? Okay? So for the times where it comes out to be just 5 knots, you're going to indent into the line a little bit. Okay? Does that make sense?
Yeah.
Okay, thank you.
Remember, if it is only 5 knots, you should have this half feather a little bit further down so that we know it's 5, not a whole feather, and you just drew it short. The next thing is cloud cover. What you do for cloud cover is you shade the percentage of the circle that's equal to the percentage of cloud cover.
So what I want you guys to do right now, in your notes, I want you to draw overcast, which is 100%, mostly cloudy, which is 75%, partly cloudy, which is 25%, and clear, which is 0%. Okay? I want you to shade in the percent for each of them. And also, guys, you are responsible for knowing that overcast means 100%. Mostly cloudy means 75%. Partly cloudy means 25% cloud cover. I'm just going to do it that way. When you're done, just put your writing utensils down. All right, you guys ready? Or you need another minute? Okay. Here, you let me know when you're done, okay? Are you done? Grace, you good? Angela, you good? You're just copying it down? Okay. Guys at home, you okay?
Yeah. Yes.
Okay, so she's gonna fill them in with you.
So the term overcast means that it's 100% cloudy, so the sky is filled with clouds. What you want to do is you just want to shade the whole entire thing here. Mostly cloudy is 75%. So what you would like to do, you should probably shade in a clockwise manner. You're going to shade 75% of the circle. Partly cloudy is about 25%, so you would shade clockwise again, about 25% of that. And clear is 0%. So you wouldn't shade anything. Sometimes what you will see is a circle drawn in the center just to show that you didn't forget to do that, but that also represents clear sky. Air pressure or barometric pressure is our next weather variable.
Okay, you're gonna wanna pay really, 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 really close attention to this one. Okay, because this is where we lose everyone. Okay, so I'm gonna explain it and then I'll let her do it as well. All right, so when you're looking at the barometric pressure, for whatever reason, they decided we are not going to write the whole number. Okay, first of all, that number will be in millibars or lowercase m, lowercase b. Okay,
Miss Gonzalez,
what's up?
will the circle ever be filled in halfway?
Yeah, there's a 50%.
Oh, I thought we only did 4.
You only did 4, but in general, there will be a 50% one. It's just in this example, she did not do it.
Okay.
All right. So, all right. When you were looking at this, you were going to look at the actual barometric pressure. All right. If the actual barometric pressure, right, is 1020.6, you are going to write that as 206 in the top right-hand corner. Okay, so if it is, where'd my eraser go? Okay, hold on. All right, if you were given the barometric pressure and you were told that you have to write it, you know, let me do it actually on the board. And you're told that you have to actually write it. Okay, this, you're just going to look at the last 3 digits. Oh, okay. Okay, sure. All right, and it'll be 2. Okay, that's not going to work. I don't know what they did. They made it into size. Okay, let's actually do a pen. All right, so, all right, you are going to look at the last 3 digits. Okay, and in the top right-hand corner, you're going to write it as 206. All right, here we're giving it, so it's going to be 894. That's if you're given the barometric pressure and you want to put it onto the station model, you're basically using the last 3 digits. Okay? If you're given, what happened?
Do we include the decimal?
No.
Okay, thank you.
No problem. All right. If you're given the station model, like this one, where we're given 115, okay, and you're asked to decipher what the actual pressure is, okay, if on the station model it's less than 500, can you guys at home see that I'm writing in red?
Yes.
Okay. Yeah. So if it's less than 500 on the station model, you're going to, let's see if I can do it in another color so you can actually see it. Okay. You're going to add a 10 in front and the decimal between the 2 numbers at the end. okay? So if the 3-digit number on the station model itself is less than 500, okay, you're going to add the 10 in front, and in between the last 2 digits, you're going to add the decimal. Okay, because obviously 115 is less than 500. So you add the 10 in front. If the number on the station model is greater than 500, you're going to add a 9 in front and the decimal between the last 2 digits. So that's the actual pressure. So the actual pressure for the first one is going to be 1,011.5 millibars. And the pressure for the second one is going to be 987.6 millibars. So you have to know that rule. And the rule is if the number on the station model is less than 500, you add a 10 in front. And then the decimal between the last 2. If the number on the station model is greater than 500, okay, you're going to add a 9 in front and the decimal between the last 2. Good? All right, awesome. Come on, play.
This value is always represented in millibars, but remember we learned in class that you could.
Sorry.
And convert that to inches of mercury. But always on the station model, we're going to represent it in millibars. Upper right, under it, I'm gonna put it back because we always have the on the station model. Okay, so here, 100, which you can see here in 876. I'm now going to add a 9 in the front. Okay, so instead of adding the 10, I'm going to add the 9 in front. So I'm going to write 987. Then I add the decimal 0.6. We always have the decimal between the last 2 digits. Next thing would be the temperature. Temperature is placed in the upper left section of the station model. It can be in Fahrenheit or Celsius. It's usually in Fahrenheit because that's what we use here. But it needs to be the same for all your temperatures. So your dew point needs to be in Fahrenheit if your temperature is in Fahrenheit. Or if your temperature is in Celsius, then your dew point needs to be Celsius. It needs to be the same on the station model, okay? So the dew point we're going to put in the lower left. Again, temperature in the upper left. Visibility is plotted between temperature and dew point, so right smack dab in the center. This is the distance that we can see in miles. So if we look at our reference table here.
Before she moves on, guys, one really important thing is I can give you a station model and ask you to find the relative humidity. But if I'm giving it to you in degrees Fahrenheit, you have to convert that information into degrees Celsius to work backwards. So keep that in mind.
Here we can see that this one says 28 is the present temperature, 27 degrees Fahrenheit is the present dew point, and then our visibility smack dab in the middle, you can only see about a half a mile on this for this station model, okay? Notice here there are no units. We only put the number for these very current conditions are symbols that are located on page 13 of your reference table. Looks just like this, so I've copied it into this box. You're going to place this between temperature and dew point right by visibility. So if it is drizzling, raining, hailing, there's freezing rain or snow, you would put that symbol.
So guys, what I'm going to do is, since this is still recording, I have next period free and nobody's in here, I'm going to keep running this video, okay, so that you can watch it again, but we will go over this again tomorrow, okay? Be good.
Right in between those variables, okay? Now, if there is no present weather, so it's not doing anything outside, you would just leave it blank. Precipitation, you are going to put the inches of precipitation for the last 6 hours, okay, to the lower right-hand side of the circle. Okay, so in the last 6 hours at this location, there was 0.4 inches of precipitation. Really important here, you'll notice that there is a decimal in this one. So you want to make sure there is a decimal placed in this one. For everything else, we're really not using that. Last thing on our station model is the pressure trend. The pressure trend will be placed in the middle right side of the circle. And this is for the past 3 hours of how the pressure has been changing, okay? So what you're going to do is you're going to remove the decimal, and then you're going to add a rising or falling slash to the end, and add a plus or minus sign to the front, okay? So let's look at this first example. It says the pressure for the last 3 hours has been rising 1.7 millibars. So what we would do is we would first need, since it's rising, we would need to use the plus sign, okay? So right here we would write plus, and then what we're going to do is we are going to write the value by removing the decimal, okay? So that sometimes is a little strange, but you're going to write plus, and then we're going to remove the decimal, so that would be 1.7. And then we have to add in the slash, which is the rising slash. So we'll add in the rising slash. So we should have what you see down here for this example, plus 1.7 and rising, okay? Go ahead and try the falling. What you would do is, again, falling, you would make sure you have the negative sign now because it's falling. You would remove the decimal, so you'd write 105, and then you need to add in, you're going to add in the falling slash, which is right here, okay? So you would go, again, negative 105 and then falling. Last thing is, what if the pressure is steady? Well, all you would do is you would just do these 2 dashes right in the center. That means in the past 3 hours, the pressure has not changed, okay? Now, sometimes you'll have to decode, so they'll ask you by looking at the station model, what is the pressure trend, or how much has the pressure changed within those 3 hours? Anytime you see the plus sign, you're going to write rising, so we know this pressure is rising. It says 17, but remember, we took the decimal out from up here, so we have to put the decimal back in, so it's 1.7, and then rising is so the plus sign, so we don't have to write that twice. So the pressure trend for the past 3 hours for this one would be 1.7 millibars rising. Okay, so we'll do a few practice with these tomorrow during class, but make sure you have everything filled out. If you need to